Let's see if we could get going. Right, good evening again. So again, this recording being done for Anita and Natalie, who are not here, unable to join us. So I was just chatting with Sulan until Kinesia arrived. Kinesia, can you chat? Oh yes, she just punched that type message in the chat. She's here. So we are once more starting our part B of our CMC question. Let me just grab that from the kit. I think it was page question number 69, our CMC co. So just getting back that page number to verify the question number. 69, yes, 69 in the kit. Question CMC co. Part B, because last day we completed part A. We did all of the 3 hedging techniques. So today we want to try and see how much of the other parts we can complete. If we can complete it within the first 40 minutes, of which we probably used 10 minutes already, that would be so great. That's what we're supposed to be doing. But if not, we could probably use 2 40-minute segments tonight and try and complete that off. So let us begin a pace. And as I was explaining a little bit before, that we do not need to illustrate the lengthy process, which would then produce the benefit or the exchanging of the cash flows. As part B clearly says, it simply needs us to demonstrate how CMC Co could benefit, and all we'll have to do for that is our short working, which we did in class, in terms of illustrating how much the benefit could be. And in this case, let us look at the question scenario again and see if there is any request or any stipulation as to how the benefit from the swap would be shared with the counterparty. So let's go here and go looking for that. So right in part 2, it says interest rate swap, contract with a counterparty where the counterparty can borrow the annual floating rate based on a yield curve plus 0.8 and a fixed rate of 3.8. And the bank would charge a fee of 20 basis points to whom? Who will that basis points 20 be charged to? Could somebody let me know in the chat? Right here, from where we're reading. Come on, ladies. I know you can see that. Not CMC alone. Who else? 20 basis points each to act as intermediary. So therefore, the total fee will not be 20 basis points by itself. The total fee, if we charge on both parties 20, could somebody let me know what the total fee will be? Come on, Kinesia. We're not here just to listen. Unless she ran away for midnight snacks. 40. Thank you very much. Now, the next thing is, which we identified when working swaps, are we told how the benefit is going to be shared? That same paragraph, right there towards the end, says both parties will benefit equally from the swap contract. So all we have to do, it's a fixed rate versus floating rate swap, and that's that. So let us go now and do our illustration. Let me try and get the page down here and see if I could start off part B. Big swap illustration. Now, how is that size? Can you all see that size that I'm typing down there? Or would you like it to be bigger? Yes. Yes to which? Can you see properly, or should I make it bigger? It's good? All right, great. So swap illustration. And again, we are lining up simply the fixed and the floating. whichever side we line that up, we're going to put those as the top heading as well. And the two institutions, we have CMC, and then we have the counter. And now we simply list the rates and then find the differences between them. So back up to the question, what do we got? We have right here, it is the counterparty data given in this paragraph. The counterparty can borrow at a floating rate plus 0.8 and fixed rate of 3.8. So floating plus 0.8, fixed rate 3.8. So going back down to record that for the counter, fixed 3.8, floating is a floating rate plus 0.8. So with that, put that on the other end. So we just need to go up and find the information now for CMC, which was further up where that was first mentioned right here. A 4-year CHF loan taken out part funding was 4 branches. From proposal 2, interest will be payable on the loan at a fixed annual rate of 2.2. So fixed is 2.2. Floating is based on the floating rate yield curve plus 0.4. So 2.2 and 0.4. Recording in our little working. Fixed is 2.2. Floating plus 0.4. Right, so we just itemize the values and we'll now go and lay out our differences. So the difference column now, within that in. So somebody could subtract for me. Oh wait, before we start to subtract, we identify. Is one company better off in both sectors? Yes or no? Yes, that's right. Who's better off? CMC. So again, remember the concept behind the swap. While CMC would be better off on its own, CMC could be even better off by achieving a further saving, no matter which type of borrowings it prefers. All right, so if it chooses to go with the fixed, which the case sort of illustrated, instead of being by itself and suffering the fixed rate of 2.2, it can save on that 2.2 and actually pay less. So that's why it will arrange with the swap or follow through or carry out the swap. So finding the differences, difference between 2.2 and 3.8 is 1.6. Thank you very much. So 1.6 goes there. And again, it's the absolute differences. Yes, 0.4 and 0.8, 0.4. And once more, we would find now the difference between those two. And we could probably put our notes since one or CMC has both rates better. That's our reason for finding the difference. If they had one rate better and one rate worse, we would have added those differences. So the difference is 1.2. Right, so this could be called total savings, if we wish. From the total savings, we will less bank's fee. Now, there was one particular question where they had additional fee of some sort, right? So whatever fees they give you to subtract, you subtract. And in this case, remember the bank fee is the 20 basis points, 20 BP, which would equate to dividing the basis points by 100, 0.2. 1 basis point, 0.2%. Well, 0.2%. So all of these values are in percentages. And of course, that's multiplied by 2 because it's charged to both companies. And that gets us 0 minus 0.4. And what will that leave us with? (1.2 minus 0.4), 0.8. And therefore, shared equally, net savings shared equally. We will now have CMC will benefit by 0.4% benefit. Right, and that's what we can write up. Put a little story to that, and we would say, thus, as CMC was planned to borrow the fixed at the fixed rate of 2.2%, they will be able to save in the swap or from the swap scenario 0.4% on this, making their effective interest rate on this loan only 1.8%. Right? And that is where we leave that. So on to the next part. Let's see how quickly we can do our question. So the next part of our question, anybody using here still? Can I go up? Save and page up. The next part of our question, C and then D, and then we are done for the night. C says, as an alternative to paying the principal on the loan as one lump sum at the end of 4 years, CMC Co could pay off the loan equal amounts over 4 years. So once you hear equal amounts, oh, they actually said it towards the end of the sentence, over the 4 years, similar to an annuity. So look at the good hints they gave you here. So they're telling you you're going to be working an annuity, and that is where you pull out your, which type of calculator? Come on, type it with me in the chat box. Pull out your financial calculators. Very good. Thank you, Kinesia. So, what do we do? In this case, we have the annual interest rate. We have the 2%. We have annual interest rate would payable, same as the loan's gross redemption yield. So we have that. We just need required. Oh, calculate the modified duration of the loan if repaid in equal amounts and explain how duration can be used. So we're just going to do modified duration. Wondering if our course notes had any shortcuts to that. Finding duration, let's see. Otherwise, we'll just switch to the manual and do our usual computation of duration. Valuation, duration. Where would we find that? So 223 in the manual, and that is Chapter 7A. So Chapter 7A is on the impact of finance, on investment decisions and so on. And that's also Chapter 7 in your course notes. So let's take a look there and see if there is a useful summary on duration or not. Formula in the exam, change in business risk, sources of finance, credit risk, overseas, estimating the credit spread, modified duration. Oh, here we go. So it's also there in the course notes, the summary. Modified duration is calculated as your macular duration over 1 plus the yield. So let's see if we would still find use for our financial calculator here. Duration 1D and 1B. Right, so lay out the cash flows. Following the example, add the present value of the cash flows in each time period together, multiply the present value of the cash flows by the time periods, and then add that together, divide the result of step 2 by the result of step 1. Now, I'd mentioned that we could use your individual present values to get those answers very quickly to discount our cash flows. So let's see if we just lay them out. Which page? We could either reference page 112 in the taught course notes or page 223 in the manual. So 112 in TCN or 223 in manual. All right, so let's just lay out a little working and get our numbers going. Right, so this is part C. Find in the modified duration. And we could simply follow that layout. We have in our question 4 years, 1, 2, 3, 4. And in each year, we'll need the equal amounts to be paid. So, cash flow. We'll need our cash flows. And then we can have our discount factor. We know we are discounting at the 2% from the question. And then that will give us present values. So we can use our financial calculators for 2 reasons. Firstly, we need to identify the annual cash flow. Which is equivalent to, if we have uh, 4 years, n equals 4, and our present value from the question PV equals to our 60,000, or is that 60 million? 60 million CHF, and then we have, what else? N equals 4, R, or our IY interest equals 2%. So with that, we could find the annual payment. Right, let's see if that works. Just punch those numbers in. Make sure and clear up your calculator. Second function, FV, to clear off the TVM, and punch some values. Punch your 4, press your N, punch your 2, press your IY, punch your 60,000 annual amount. Now, I just need to double check if the 60,000 is the final amount or the initial amount. I think that's the final, yeah, so it should be the FV. That's right. So I already have it. There's the PV. I could change it if it's not. So IY is 2, and if 60 is my PV, compute payment 157,574. Okay, that looks close enough. So that looks like it. If I did 0 as the PV and now 60 as the FV, compute payment, yeah, that gives me a different value. So we have it right. So once we punch those in and we press compute payment, we will now get something very close to the answer. So once more, we will now have 15. Again, we could choose to work in millions, or I'll write out the number they have: 157,57425. Right? Did anyone else get that using their calculators? Punch those and punch compute payment. Yes, excellent. Now, of course, you have to watch out for your decimals. If you use the full 60 million, you will still be very good. I just used the 60 and had all the decimals. Kinesia, how's the financial calculator working for you so far? Nope. Okay. Let's see. Make sure and clear it off first. Second function, clear TVM. Then press the 4. Then press N. Then press 60. You could probably put in all the zeros, 60 million. Then press the PV. Press the 2. Press the IY. And then just hit compute and payment. Anything? I could put on the camera here and then, okay, great. And then show you what to do, right? But once you're successful there, excellent. So comparing this to the kit answer, at this stage, what did they do to get that 15 million annual payment? They took the long route and had to go to the tables to get the 4-year annuity factor, which was 808, and then do a division of the total divided by the 3.808, right? So we have this wonderful shortcut. It's clearing the cash flows. All right, so second function, FV, declare the TVM because we were using TVM button, not the cash flows button. Very good, no problem. More practice with your calculator and you will be fine. So our cash flows are now 15,757. We could use our values. 757, 425, 425, and copy that across for 4 years. Okay. I just scroll down too far. Let me get back to where I am supposed to be. Right. Right. So now that we have these, and I think I just edited some of those writings there, which I shouldn't have, but I'll say about that later. Yeah, it's not so bad. It's not so bad. Should still be good. Right. So to get them as present values quickly now, instead of using the discount factors from each year, which is the long method, which the get answer takes you through, all we need to do now is keep that value. Okay, now we need to clear our present values first. Second function, clear TVM, clear off calculator. Then taking 15,757, 425 in your calculator. With that, you press future value, FV. So 15,757, 425, in other words, the annual cash flow. Press FV. Then press 2, press your IY. And the N value is what we will be changing from 1, 2, 3, and 4. And each time we change it, we will record our present value. Right? So I'll say that again. The IY, which was 2%, the last thing we entered, that's going to remain the same. Percentage is the same. The cash flow is the same. What we need is the different years. And from the different years, we will get the different present values. All right? So let's go. Everybody has those two things in the calculator already? Can I see by a type of yes? We have the cash flow in and we have the IY in as the two. Yay or nay? No? Come on, Sulan. Punch those in. Right, we have 10 more minutes in this free meeting. Then we'll start with another meeting after the next 10 minutes. So punch in the 15,757, 425. Press FV. And then punch the 2%, press IY, and then type yes in the chat box. Nisha, are you ready? Hello. Kinesia, are you there? Sulan's ready. Great. So once you have those two entered, now press 1 and press N. And after you press 1 and N, then press compute PV. And you should have a value of 15. Might show up negative, but that's okay. 15,448, 456. Write that down for year 1. Now don't clear anything in the calculator. Keep that value there, write it down, and then get ready and tell me when you're both ready. Have we written it down? Are we ready? Type with a little yes or Y, so I know everybody's ready for the next one. Excuse me. Sulan's ready. Can you say, are you ready for the next year? Good. So leaving everything in your calculator as it is. Do not clear anything. Simply press 2, press the N, and then press compute PV again. And a new number will show up, and write that down. That's the second year present value. 15145 Are we getting that? Type a yes when we're ready to do the third year. Oh no, what did you get? Three zero. No, something's up there. All right, so did you get the first one, Sulan? 15448,456. All right, so don't know what you pressed. All right, so we will now need to clear the calculator, press second function FV, and start again. Punch the cash flow line 15757,425 and press FV. That's the future value. Then press the 2, press the IY. Then we can double check by doing the first one. Press 1, press the N, and then compute PV. Not payment. You're not pressing PMT. We're pressing PV for the present value. Okay, what's the no, Sulan? Where are you at? Alrighty, so let me put on the video and try and show Sulan here. 1 second, what we can do. All right, video. Okay. What's up with this AVG thing? All right, firstly, AVG is giving me some trouble here. It's silly. Escape away from that. Move this window. I can't remove this window. That's so silly. All right, so, oops. So that. Right, so let me hit the camera here, start video, and let's see what Sulan can see. So clearing my calculator here. Now I cannot see myself. So let me stop the share, pause the share, and see what I can see. If I could see myself, then I could see what Sulan's seeing, right? So remaining time 3 minutes. So I have 3 minutes to show Sulan this operation. The first thing we needed was the annual cash flow. Let me just move this around so I could see my numbers. Right. So I'm sure you could do the first bit. 15757,425. Right. So watch me now, and I am pressing the FV. So that's the future value. Right, FV over there. Now that you have that as a future value, we then press the 2, and 2 is the IY button. IY. So press IY. I think I hit PV. IY. right? The next thing is the end. So we press 1, well, 1, and then we hit the end. And over there. So it says n equal 1. Now we go compute and PV. And when we do that, we will get your 15448 456. All right, so let's see in the chat. Are we getting that? Hold on, Kinesia didn't get it either. Salon got it now. Kinesia, where are you? Where are you with the computation? Yeah, I punched PV by mistake the first time. But PV, the middle one, P instead of FV. Yeah, don't do that. So the 15 million is on the FV, and we are computing the PV. So you're pressing the FV when you enter the 15 million, and when you press compute, then you are pressing the PV in the middle after you hit compute. So compute, then PV. So we're calculating the present values, and that is what our wonderful calculator helps us do. All right, so switching out the video now, back to regular. I'm back to sharing the screen. Kinesia, are you there? Have you found our values? Great. So the next step is keeping those values in the calculator. Don't clear anything. Keeping that value in the calculator. Press 3, press N, and then press compute, press back P.